Alright, so today we'll be finishing off the first semester of AP Calculus, ABA, with numerical integration, and we'll be talking about the trapezoidal rule and Simpson's rule. Okay, trapezoidal rule is instead of our usual rectangles, we would actually use a trapezoid for this. Now this is really good for linear functions because linear functions follow along the same lines. But basically, the area for a trapezoid is the, let me see, what is it, 1/2 of the height, which would be b minus a in this case. So it's basically all of this in here. Okay, so this would be the height, and then this would be the base 1 plus base 2, and then this would be the 1/2 that's divided by 2. So it would just be that. Now if I needed to do multiple points, multiple trapezoids, as you can see, the more trapezoids I get, the better and closer approximation I get. And they take care of that issue, whereas with the rectangles, we just kind of made it either a midpoint or a left endpoint or a right endpoint for our integration and everything. But the trapezoids actually stay pretty well underneath the curve, and if not, get so close that we don't have to worry too much about it. Okay? Alright, so that's that one right there. And obviously, the infinite amount of trapezoids I have, the higher in value I'm going to go. Okay, now Simpson's rule is the other one we'll explore, and this is just saying, okay, what about a higher order polynomial to go under this? Now, I'm not a big fan of the actual drawing, so this one should actually be kind of looking like this. There we go. Okay, so as you can see, the higher order polynomial that goes underneath this one, okay, it's going to look really good for the actual area. And of course, obviously it's missing here, but it's making up for it right here, so it's going to cover it really well. Now this is just an example, 3 function values. In other words, there's 3 points where they intersect. This isn't that example, but it would kind of look like this, b minus a of f of x sub 0 plus 4 times the f of x sub 1 when we plugged in that value, and then plus f of x sub 2 divided by 6. Okay, and so that would be those type of rules for numerical integration. Now obviously this at all in no way, shape, or form makes up for the plain old integration that we have, but these are just numerical integrations that a lot of people had trouble with. And this, once again, this is coming from the idea of this, let me see, f of x dx, and obviously these were all methods that were used before, and then this just became f before the fundamental theorem of calculus and stuff. Alright, and then let's do boom. Okay, this is, I mean, these are just different ways of rewriting this type of formula, and once again, these are approximations, so they won't be as exact as the actual integral will. Okay, alright, that's it for first semester. I'll talk to you guys later. Bye.